Welcome to another data science deep dive on our technical track. In the following presentation, Rossi, data scientist at Foursquare, discusses the challenges and implementations of passive data collection that data scientists face, zooming in on how to tackle consumer privacy and uncontrollable outside effects on data sets. Passive collection helps modernize today's advertising practices to become more practical and agile, but in order to get there, it's very important to recognize the challenges and how to overcome them. Enjoy this presentation.
Hi, everyone. Thanks so much for joining us today. My name is Rossi, and I'm going to talk about navigating through the new age challenges of passively collected data sets. But first, a little bit about me. For most of my career, I've been focusing on consumer source data and insights. Right now, I'm a data scientist at Foursquare, the location technology company. But prior to working in data science, I was actually a product manager building insights products using consumer source data. I worked at Nielsen, the global market research company, for 7 years, mainly focused on their consumer purchase panel. As we saw the cost of data acquisition going down with the growth of smartphones and smartphone apps and new competitors rising to take advantage of these new methods, I worked on several proof of concepts to also capitalize on these new methods. Now at Foursquare, I get to work with these new age methods of consumer data collection using our first party always on mobile panel to derive visitation insights for our clients. With this experience, I think I have a unique perspective to talk to you today about managed panels, as well as the rise of new passive methods of consumer data capture. However, these new methods don't come without challenges. I'm also going to talk today about how to tackle some of the challenges inherent in these new methods, namely how to interpret and validate this data, and also outside events that might shake up your data collection. Consumer insights derived from data sets tracking consumer behavior over time are invaluable to advertisers, especially now. While in the past, consumer spending was focused primarily on a few major retail channels, consumer channel proliferation with the rise of direct-to-consumer, specialty stores, niche brands, etc., means that marketers must have a good grasp of what's going on with omni-channel consumer behavior. The COVID-19 pandemic has also presented major challenges as it works to reset consumers' behaviors and preferences. Keeping close watch on these major market changes and their impacts and staying nimble in response is key to businesses surviving this time. These longitudinal consumer insights were traditionally sourced from managed consumer panels such as Nielsen's HomeScan purchase panel. HomeScan panelists are recruited and offered incentives in exchange for tracking their purchase behaviors over time, which are then projected and normalized to represent total population. The image here shows the traditional way that HomeScan panelists report their purchases. After a shopping trip, panelists will scan the barcode of every product and enter the price paid. The benefits of a managed panel are that underrepresented groups can be specially targeted and recruited to ensure representation. For example, in the HomeScan panel, recruiters go door to door in certain markets to recruit face-to-face Spanish language dominant households to ensure that they're represented. However, a managed panel also introduces bias. Incentives can attract deal-sensitive panelists, and self-reporting bias is inherent. All of the overhead of recruitment, incentives, it means that managed panels are really expensive, and therefore they have a limit on how high they can scale. The HomeScan panel is about 100,000 US households, which works pretty well for some use cases, but more granular needs like going down to market level or a shorter time period is where they really struggle. With the proliferation of smartphones and smartphone apps, the cost of collecting consumer behavioral data has never been lower. Companies have been taking advantage of this using techniques such as email receipt scraping, gamified consumer apps, and in the case of Foursquare, mobile location services. They offer consumers new kinds of benefits in exchange for their data. The low acquisition cost means that panels can be scaled up and achieve much higher granularity than traditional offerings. Also, self-reporting bias is mitigated. Foursquare's use of background location enables multiple daily visits to be collected without any workload on the panelist. To manage sampling bias, companies may also utilize multiple collection techniques or offer different types of apps to target different swaths of the population. However, with smartphone penetration not being at 100%, there definitely is still some sampling bias in this method. The first screenshot you see on the right there with the pig is Numerator's Receipt Hog app. It's a gamified app where users may earn rewards by taking pictures of their receipts. While this is still considered, self-reported data, Receipt Hog is an example of how a small startup could grow a panel of 500,000 users pretty quickly to take on the big market research firms. Email scraping, a completely passive technique, is another method used by Numerator for their omnichannel insights, but also a company called Rakuten with their Slice app, which is pictured all the way on the right side. By providing Slice access to their email accounts, users get an app that tracks shipping for their online purchases, and Rakuten is able to scrape their email purchase receipts to give their clients a view of the e-commerce market. Foursquare's first-party location panel consists of millions of people who have consented to share always-on location in exchange for location utility. We have 3 owned and operated apps: Swarm, which is a check-in app to let your friends know where you are; City Guide, which provides recommendations on where to eat, shop, visit in all different cities; and Panel app, which is a rewards-based survey app. We also work with SDK partners such as the popular couponing company, who recognizes the value of location context for their users. This panel has provided valuable insights to our clients on how COVID-19 has impacted visitation to places like grocery stores, fast food restaurants, parks, etc. And it's enabled them to track recovery in a really granular way, by market, by category, by chain, by week, even by consumer segment. But while passive consumer data collection has many benefits over managed consumer panels, practitioners adopting these techniques face several challenges. I'm going to go through 2 relevant challenges with passive data collection. The first is interpretation and validation. Passive collection enables us to collect much more consumer behavior as it happens without the bias introduced through self-reporting. However, the burden is now on the collector to actually interpret and validate the data to turn it into something meaningful. For example, when moving from asking panelists to scan barcodes on products to instead take photos of shopping receipts, like you see there on the right, you lose some control of the data collection. Instead of panelists sending the actual stock keeping unit or SKU code and selecting from a predefined store list of where they shopped, companies have to convert the receipt images to text and then figure out the store and the items just from the information on the receipt. Some retailers actually print the SKU code on the receipt, but many don't. And in the case of this Dollar Tree receipt, you can see the brand name isn't even in the item description. Foursquare has had to solve this problem too. Foursquare was initially launched as a consumer app where users would check in to share where they were with friends. We realized, though, that to make this technology truly magical, we needed to eliminate the check-in button and make checking in passive, requiring absolutely no user action. We had to make a technology that could understand where you were in the real world in real time without having to take your phone out of your pocket and press a button. Just like the receipt example, we were going from self-reported and validated data to just receiving mobile phone signals that we needed to interpret and make meaningful. To do this, we had to solve 2 discrete problems. The first, stop detection, involves understanding motion patterns so that we can identify when a person is actually visiting a place versus just walking by. Place detection is understanding where a phone is actually located once we determine that it has stopped. So first, getting into stop detection, we built a battery-sensitive, real-time visit detection method that could quickly identify true visits while being resistant to ephemeral motion changes, such as being stopped at a red light. We approach this problem as a state machine driven by moving averages of velocity. And we aim to make it extremely sensitive to foot traffic patterns versus driving, biking, other forms of transportation. We were able to tune this algorithm to best match and predict our ground truth corpus of check-ins. Our second interpretation and validation problem was, once we determine that a phone is in a visit state, we have to figure out what's the place. This is actually a really difficult problem. And I think, we all rely on navigation apps and mapping apps and, rideshare apps. So we probably feel like our phone has pretty good sense of where we are. But in a lot of cases, pretty good is not good enough. I don't know about you, but I've definitely had my phone get my location wrong. I feel like, I use rideshare a lot. I'm constantly running several blocks or, crossing a busy avenue against a light so that I get to where the rideshare actually thinks I am on time. We like to call this the blue dot problem, and it illustrates a really important challenge that raw location is imperfect. The problem also varies based on where you are. When the venue is a rural Walmart with a large footprint and sparse surroundings, the problem can be a bit easier to solve. But crowded city blocks with vertical stacking where GPS is sort of just bouncing around against buildings, it becomes much more challenging. When I worked at Nielsen, I worked in the financial district in New York, which is an area with very narrow streets, very tall buildings, very, very dense. I would get lost all the time, even after working there for a year, because my blue dot on my map was always like completely far away from where I thought I actually was. So especially in cities with tremendous density like New York, this means the difference between placing a user in the steakhouse or the vegan restaurant next door. And these are very different types of people. It's really important to get this right for developers who want to send a coupon or a real-time notification based on where a phone is located. Here's a real example of the problem with real data. Here we're showing 3 distinct places on adjacent corners in Manhattan. The dots represent the location of phone reported while a user was visiting one of these places. You can plainly see that small variations can lead to very different meanings. But as hard as this problem is, we actually had an advantage. If you remember the active check-ins that I mentioned a few slides ago, we had a unique and priceless data set of check-ins and places around the world that allowed us to approach this problem in a novel way. We had what we called the phone's eye view of the world. We as humans, we see streets and street corners, buildings and storefronts. We see the world very much the way a cartographer creates a map, but a phone sees the world in a very different way. Many different dimensions, powered by different sensors such as GPS, horizontal accuracy, Wi-Fi access points, and Bluetooth LE. Check-ins allowed us to remap the world the way a phone sees it, using what we call place shapes, which are more amorphous place shapes, as you see in this image here. Other location data providers use methods like radii or polygons to build their map of the world, which are subject to the systematic distortions of GPS. For example, if we had used polygons instead of place shapes, we would have shown the user here on the slide to be in the steakhouse and not in the vegan restaurant, which is next door. Our corpus of check-ins and the ML-based algorithm that we've developed, which we call venue search, allows us to map and recall the way the world looks to a phone across all of these dimensions. So when a phone comes to a stop, we use all sensor readings to model, rank, and assign visit probabilities to the place a user is visiting. This all happens seamlessly in the background of your phone to truly enable us to understand where users are, which powers not only our consumer insights, but also the developer use cases that I mentioned earlier. We just talked about the interpretation and validation challenges present with passive data collection. Next, I want to dive into the second challenge of events outside of your control. Given that passive data collection, first and foremost, involves giving up some control over collection of data, we need to understand that outside events can affect panel size, composition, even trend. The COVID-19 pandemic is one such example, but changes to partner apps and mobile operating system rollouts and consumer data privacy developments also qualify. COVID-19 was a majorly disruptive event for Foursquare's panel, and I can imagine many other data providers as well, because our panel depends on consumers visiting public locations. So in the early months of the pandemic, raw visits saw really large declines, as you can see on this chart here in blue. The chart shows the panel's trended raw visits to public venues last year, as well as the normalized visits in orange. You can see the decrease in raw visits, mainly due to people staying indoors, but it's also from a decline in active panelists. During a pandemic, the value propositions of some of our partner apps may not be as relevant, and users might, turn off background location or even delete apps. Also, our panel is biased toward coastal urban users who experience a larger relative drop than total population during this time. You can see that our normalization scheme, which balances and upweights active user visits to match US Census, is working to transform the raw visits into what we believe is a more accurate representation of US behavior during the pandemic. Another major outside factor is technology changes with your collection methods, such as partner app updates and new mobile operating system rollouts. The chart here shows how changes to partner apps, such as turning throttling off and on, which some partners do as a temporary cost-saving measure, can lead to disruptive change in active user counts and therefore visits. To mitigate, I'll do that one again. To mitigate against tech change impacts, we need to be nimble with normalization techniques to maintain a balanced representative panel. Also, having diverse data sources lets us confirm when trends like these are not true consumer behavior. The chart at the top is the one from the previous slide, where a partner app turned throttling off and on, resulting in a spike in active users, as you can see in orange. The bottom chart shows the resultant raw visits in purple across our entire panel. We see that this partner's throttling really disrupted things for us. However, the normalized visit trend in teal is unmarred by these changes. Our current normalization, though, is sensitive to fluctuations in visits per user, also called frequency, coming from partner and technology changes. So to add further stability, we're actually researching incorporating additional factors into our normalization scheme, such as mobile operating system version and SDK version, which we think can serve as surrogates for visit frequency or visits per user. I also wanted to double click on one of the major impacts of mobile operating system rollouts these days, since I feel like it's really important to highlight. Consumer data privacy has risen as a growing concern, exemplified by new regulations such as GDPR in the EU and CCPA in California. And therefore, new mobile app versions have made changes to address it. Consumers are growing wary about what companies are doing with their data, and often with good reason. Regulations such as GDPR and OS rollouts like iOS 13 and 14 give consumers more transparency into and the right to opt out of data collection. This is a good thing, which I think as practitioners and consumers, we all should be in support of. But it's something that, companies passively sourcing consumer data need to keep apprised of and make sure we stay on the right side of. To solve this, companies need to provide a value exchange to consumers. Foursquare feels that people should benefit from having location data collected, and therefore our tech is not available to app developers who don't provide these benefits. Also, giving consumers control over whether they would like to share their data, as well as being transparent in describing how their data will be used, are essential to ethically and sustainably building a passively sourced consumer data set. This slide shows the iOS 14 location permission prompt flow within Foursquare's City Guide app. Last fall, Apple released iOS 14 and introduced new features that aim to give users more granular control over how and when apps can collect this data. By explaining the value provided to consumers by sharing precise, always-on location, we found that a large majority of users continued to share their location with us, which is really great. In summary, the trend has been moving away from expensive managed panels toward passive data collection, often using smartphone apps to derive granular consumer insights at scale. Even the traditional market research firms are pursuing this strategy now, using gamified apps to fill in coverage and working with email scrapers to develop omni-channel panels. While there are many challenges of working with passive consumer data sets today, the cost, scale, and bias benefits are clear. I'm excited to continue to research passive data collection and work on new ways to make this data even more valuable. Thank you.
That was Ali Rossi, data scientist at Foursquare, with her presentation on the challenges and implementations of passive data collection, focusing on how to tackle consumer privacy and uncontrollable outside effects on datasets. If you'd like to watch more content like this, you could subscribe to the DSS Insider program, where you could see a complete on-demand video repository of the wide range of topics just like this one. The link is in the comments section. Enjoy!